you have any questions to it, Min-chan?
Question 31.
Okay, 30, 39, 42. Let's do those questions for now. Thirty. Okay, start from 30. It was, I think 2019 North Sydney or 820 North Sydney boys used that question in their trials. So, yeah. 30. A bundle of the fireworks is launched from the Central Point Tower in the Sydney, 305 meters above the ground. It is launched with the velocity of the 45 meters per second and an angle of 30 degrees above the horizontal. The fireworks explode at a safe height of 280 meters above the ground like this. A, what is the initial velocity? So pretty easy to find initial velocity by now. So you know, make sure you draw a vector diagram. So 45 meters per second launched in the 30 degrees like this. So vertical component means that you need to find the uy here. So uy, as we're given, there's a 45 sine 30. Yep, and what'd you get? 22.5, which is half, yeah. Meter per second. And direction is upwards. This is tricky. So vertical, even though this is a vertical velocity, remember, same for your yearly exam coming, guys. If you had a question about velocity, it means that you must talk about the direction. Yep, so it was going upwards in that case. B. Dwight, can you see the screen? Can you see the board? Okay. B. What is the maximum height reached by the firework before they explode? Same. Same. Vy at max height is Vy. The final vertical velocity at the maximum height is 0. Simple as that. When we reach the maximum height, the vertical, it seems like it's not moving further up or down. Means that this is equals to Vy is equals to 0 is equals to Uyt plus Uy plus half Ayt, where the Ay is minus 9.8 meter per second squared. Therefore, now we can use that 22.5. So T is equals to 22.5 divided by 9.8. You'll get 2.30 seconds for the time taken. For the maximum height now, Sy is equals to Uyt plus half Ayt squared. I ask you to memorize that for your yearly as well too. So that is equals to Uy is given 22.5 times time taken, 2.3, plus that 2, half times Ay, which is minus 9.8, times the 2, 2.3 square. My tip, my advice is, you probably have to save some exact value of the time in your calculator. Okay, use that as an answer. Okay, and then substitute the 22.5 times answer. Yep, plus the 2, half times 0.5 times minus 9.8 times the answer square. Then you get, that's giving you 25.83 meter. Are we done? No, we need to find the maximum height above this tower. Therefore, the final max height is 305 plus that 25.83, which is 328.8. So in a given sig figs value, 2 sig figs, it'll be 329 meter in 3 sig figs. Yes? Pardon?
Wouldn't it be 331?
Oh, it's actually 31, sorry. 31 meter. Good. So questions are quite repeat. In the projectile motion calculation, questions are repeatable. Like they're repeated again, again, again. So using the same methods for the working out. See how long after the launch do the firework explode? How long the launch? And after the launch, the firework explode. So the question is asking you to find the range. Is Sx, that is equals to U, X and T, where Ux is the given condition here. If you found it from the question A, that would be fine too. Doesn't really matter. Is equals to 45 cos 30. You can use the exact value if you like to. So the 45 root 3 on 2. If you like to use that, meter per seconds. Therefore, the total time taken, if you can think about it, is not the time from here to there. Do you realize that? Because the time taken, if there's a time 1, it will be time 2, time 1 again up to the same 305 meter. But if you realize that the firework actually exploded in 280 meter, which is below the 305, so you need to find the total time taken again by using this. What is the final displacement? The final SY in that case, thinking about the final position minus the initial position, which we learned in year 11 again, that is 280 minus that 305, giving you the 25 minus 25 meter down. Okay, SY is also equals to minus 25 meter is equals to UYT plus half AYT squared there. How many marks for that actually? Should be more. Yep. Typo, most likely. It can't be a 2 marks question. Anyways, let's do this. Uy is given here, which is 22.5 given, so minus 25 is equals to 22.5 t plus that to minus 4.9 t squared. Yep, then t is equals to, move that, so let's move that first. You get 4.9 t squared minus 22.5 t minus 25 equals to 0. T, using the quadratic, is minus b, 22.5 plus root b squared, 22.5 squared minus that 4ac, 4 times 4.9 times minus 25 divided by 2a, 9.8. Find this, the one in the that 4 times 4.9 times the minus 2.5 square root of that and plus 2.2 and 2.5 and divided by 9.8, and you should get 4.7 second fully the total time taken. Then Sx should be 45 root 3 on 2 times 4.7, that is that times 45 times root 3 divided by 2, you'd get 183.2. So in the 3-6 fix, it would be 183 meter. Yeah, I times that 4.9 to a. Quadratic, any problem with the quadratic?
I get 1.5
Hmm?
5.52.
What is that again?
5.52.
For the time?
Yeah.
I'll try it again. Indeed, I got a 5.5. Sorry, must be a calculation error. The 5.5. That means that 5.5. My bad. Getting old. Okay, times 45 times root 3 and divided by 2. So did you guys get 215? For the final answer. Good. But do you see the working out here are very similar to the we've been doing? We don't change the working outs a lot. If you get some change working out question, yes, I think that will be the hardest question you can get a projectile motion. But yet, that's when you're preparing for trials next year. Okay. For now, the possible question in the school exam is this is the hardest one you can get yet. So don't get afraid of like, oh, they're too hard. Don't get afraid of those questions. Once you get used to with finding this, it's more about this SY. Actually, many students missed out that. They just use the time taken from here, which is wrong. Minchan, 39 did you say?
Oh, yeah.
Okay. A toy bird is launched at 60 degrees to the horizontal from the point 45 meters away from the base of the cliff. Calculate the magnitude of the required launch velocity such that the toy bird strikes the base of the wooden building at the top of the cliff 34 meters above the launch height. All right, interesting question again. Again, that's HSC questions we had. So thinking about the question asking to find the launch velocity, which is u. That's the question. What the question is asking, and it's you're given that angle is 60 degrees over here. So first of all, can we think that the range and that covered by this there too? Sy from the given situation here is given at 34 meters first. Sx, which is range, is given at 45 meter, which is u, x and t. Okay, from here, Sy 34 is also given as uy t plus half ay t squared from there. Okay, we can't assume that. We can't make an assume that these are the this is the maximum point, maximum height. We can't make an assumption that the vy is a 0. You can't do this in here. Looks tricky, but if you think about the u, that if that's a u, still I'm going to use a very similar concept, ux and uy. That ux is, if it's given at 60 degrees here, is equals to ux equals to u cos 60, which is half u. Uy is u sine 60, that's root 3 on 2 u here. Okay, what I'm going to do is I'm going to substitute that over here, that the 45 is then equals to, or in terms of time from Sx, t is equals to 45 divided by ux from the equation here, that ux is given as half u. Can I substitute that over here? I think we can. I can. Then I can make ux as half u, so that'll be 90 u for the time taken. Good up to here? Okay. Can I just resubstitute back over here? Then 34, then substitute back into here. Then you get uy, which is root 3 on 2. So 34 is equals to root 3 on u, which is uy, times the t, 90u, plus the half ay, which is minus 9.8, times the t squared, which is 90u squared, like this. Everyone good up to here? Okay. Expand them, then you would get 34 is equals to the 90u and times that too, so that'll be 45 root 3 u squared plus that to minus 4.9 times 90 squared, which is 810 u squared, like this. Looks confused? So what is 110? 90 square. Oh, actually 8,000. That times 4.9. So that's 45 root 3 u square minus 39690 u square is equal to 34. Good up to here. Okay. So what did this do? 45. So u square comes out. 45 root 3 minus 39690. Minus 3969. Oh. Go minus that. Oh. Can't be. Hang on. Missing something. Uy minus 9.8. Uyt plus half ayt square. 90u. Cos 60. Yep, half u. Substitute into 1, 34. I'll try it again from here. So for substituting that, 34 is equal to uy, which is root 3 on 2, u times the 2, 90u, minus 4.9 times the 2, t squared, which is 90u squared. That is equals to 34. Given. I'm sure that is the right one.
You
can velocity formula.
Yeah, because to find uy, you guys need t to use the v squared. Since we already have displacement, acceleration, and final velocity.
So the Vy, no. Sorry, say it again. Sorry.
Since 34 would be the highest point, since you're counting with the balls, another.
Well, this is the thing. We don't know whether 34 is the highest or lowest in that case. So this is why it's a bit risky to make an assumption like that.
So that's the base of the. So that's the base of the.
Base of the cliff, which is a 34 meter there. Okay, away from the base. Oh, yeah. And if let's read the questions. Strike the base of the wooden building. Yeah, I'm concerning like that it could be like this. If you're hitting the base of the building, there'll be a projectile from going like this, or like this. So whether that or that, we don't know. So this is why I can't. Okay, it'll be easier if we can add this a maximum point and simply make Vy to 0 to find the answer. That'll be much easier. That means we don't need this. We simply need that. But here, no, it won't be like that, I assume. So I'm thinking about like those answers. I'll have a look at these answers later too, and let you know. For now, because we spend a little more time on that. All right. Next one was 40 what?
42.
Oh, the last one. Okay. A balloon with the basket attached moves vertically towards the ground. As it descends, it maintains a constant velocity of 3 meters per second. A can of drink slides across the horizontal floor of the basket at 1.2 meters per second. All right, it slides out of a gap in the side of the basket 10 seconds before the basket hits the ground. How high is the floor of the basket above the ground when the can leaves the basket? Oh. It slides out the gap in the slides before the basket hits the ground. Okay. Can drinks and slides across the horizontal floor, basket 1.2 meters per second, and descends, maintain constant velocity of 3 meters per second. Okay. Oh. Tricky. Slice a gap in the side of the basket 10 seconds before the basket. 10 seconds before the basket hits the ground. Ooh. How high is the floor of the basket above the ground when the can leaves the basket? Seconds before the basket hits the ground. So the Vy constant velocity of that is given as 3.0 meters per second, first of all. The can is sliced at the Ux is constantly sliding into 1 meters per second forward. It slides at the gap in the side of the basket 10 seconds before the basket hits the ground. It means that before the basket, okay, the time taken from A, confusing, time taken for the basket to hit the ground is 10 seconds after the can left the basket here. How high the floor of the basket above the ground when the can leaves the basket? Okay, means that we are given this, first of all, and it is descending in this constant velocity of the 3 meters per second squared. Simple, means we can find the distance or displacement is equals to your velocity times the time. So as the balloon is descending in 3 meters per second, okay, means that 3 times that 2, as it was descending 10 seconds after the can left the basket, it would be 30 meter down for A. Yeah? Because the question asking you how high is the floor of the basket above the ground when the can leaves the basket. So after can left the basket, it went down for another 10 seconds. So it's more about how to analyze the question rather than the projectile yet. B, what is the vertical component of the can's velocity as it leaves the basket? So, you know, we can just assume that when can leaves the basket there, okay, it was actually descending first of all. So when can, from the floor of the basket here, when can just left over here, it will have the horizontal velocity of the Ux 1.2 meters per second, first of all. But it was as it was moving down initially, initial velocity will be this, going down in 3.0 meters per second like this. Yep, can was actually descending down. It's not like a free fall from the stand here. It was moving down at the same time to falling down too. So it was gaining some velocity of the balloons, which is 3 meters per second down. Vertical component of the can would be, therefore, the Vy of the can would be 3.0 meter per second down. Or the question B. See, how long does it take to can of the drink to hit the ground once it leaves the balloon? Okay. Will the can have the same vertical velocity down once it's falling down?
Yes.
Yes. What do you think?
Or
No. What do you think?
Wait, the can?
The can, yeah.
When it falls down.
When it falls down,
Is it the same as?
do you think it will be the same velocity, 3 meters per second down?
Yep.
No. Now, 2 no's. It's like, you can imagine this. Like you're smashing something down, like assume that you're in the really high cliff and you are kind of smashing something, you're throwing something downwards too. Okay, do you think that smashing like this, you're throwing object, let's say a tennis ball, for example, okay, do you think the tennis ball will maintain the same velocity you threw, or will it gain some acceleration? It will gain some acceleration, means that it will have some change in velocity, and acceleration, AY, is always be minus 9.8 meter per second squared there. The reason why we are confused, I know, is because of the balloon. But imagine balloon can maintain, have a thrust, have the balloon can't air resistant to go against to the acceleration of the gravity. But I don't think like can of the drink would not have much of this. And questions that specify that ignore the air resistance there as well too. Which means that this AY comes down. So what we need to find, how long does it take? Do we know the displacement? We do. This is why you get question A, B, and C separately here. So you can use SY is equals to UYT plus half AYT square again, which is 30 meter, which is going down. So I will have to take that minus 30 is equals to UY, which is going down, minus 3T. This is the difference between the other questions we had, plus that half of the, so I just write in the minus 4.9 T squared like this. Okay? Then, or you can use the energy here, that gravitational potential energy and kinetic energy if you would like to, or just stick on that. Okay, doesn't matter. So what we get is 4.9 T squared plus 3T minus 30 is equals to 0. Therefore, T is equals to minus B minus 3 plus root 3 squared minus 4 times 4.9 times minus 30 divided by 9.8. So 3 squared minus 4 times 4.9 times minus 3 and square root of that, and minus 3 and divided by 9.8. It will take about, oh, it's actually really fun. Did you guys get the 0.534 different time? Let's try it again. Might be my calculation again. Oh, sorry. Yeah, it is my calculation. I didn't put the 0 there. Did you get 2.2 seconds in 2 seconds? So it will take about 2.2 seconds. So compared to the balloon, as you're kind of smashed, on the can to the floor, you will only take a 2.2 seconds. So this is very similar to the current HSC questions these days. Okay, it's like using some of the contents you learned. So this is probably the question we're going to try later too. Some very similar type of question when you're trying for your preparing for HSC. So not the trials. Trials we don't get this type of question many. It'll be very straightforward. I've been looking at your school's paper. Yes, it was very straightforward. And same for that other school too. Same for your school too. Because we are buying papers from the third parties, and they're making the very similar style questions these days. This is more in the HSC, so this is probably what we practice later next year. So don't worry about it for even if you don't understand this question, don't worry about it for now. But do you get it? Good. There's D. There's D. Oh, sorry. How far apart will the initial impact sites of the basket with the can of drink? It will be easy. Assume that balloon will be just vertically going down, so there will be no change in there. It's a horizontal. Yeah, but the can, remember, can has UX of 1.2 meters per second initially, and we assume that there's no air resistance, and this will be same as your Vx. Therefore, we can use for question D the Sx, which is the range of the can we dropped, will be Ux and T, that is 1.2 times time taken for the can to drop, not the balloon. Can will drop it in 2.2. It means that 2.64 meter ahead of these. So whilst the balloon will be dropping in this point over here, the can from here will be dropped in 1.2 meter ahead of the balloon. But you will probably see like the can will be dropped in 2.2 seconds first. So you will see the can drop first, and then balloon will be slowly descending down in 10 seconds. So that'll be the final answer. Again, using some of the projectile concept here. But it's more about how to imagine the situation here. This is not an I would say interesting question. It's not like something untouchable. once you know how to do the question, it's very like the same working out. I didn't use anything new here. Always the same motion equations, always the same. So quick tip for your yearlies too. Yes, you can get a very tricky question in your yearlies. By the way, I give you some prints for the yearly papers to practice. You can practice today, so you can practice at home. And I will post up I will give you the answer as well for that. Okay. All right. Any other? Okay, that was the last question. So no more questions for this paper, I assume. All right. Enough of the projectile for a while. We will come back to the projectile in your holiday. Okay.